enough.
Okay. So welcome to, today is the fifth day or the fifth session, fifth or sixth, I think the sixth session. So we will be continuing with where we left yesterday. Yesterday we looked at engineering design. We looked at the kind of material properties and how they affect the way they affect 3D printing, the strength. We looked at how flexibility can affect, or how you can be able to print out of flexible material. We looked at how to print, or we looked at this where you can print as an assembly, or you can print multiple parts together. We did look at how 3D printing has been used to create some arts, and these slides I think will be shared. Then we looked at the engineering design process yesterday. Can you hear me?
Yes.
Yes. Why is CK saying she can't hear me? And
Maybe,
Michelle, I think.
Maybe.
And
it's
mute
Michelle.
on your, mute.
It's Michelle
Yes.
who can't hear you, so that's why I'm telling her to connect to audio, but she has already done that, so I don't know.
Okay. Yeah. So we looked at the engineering design process, or there is something called design thinking, which is used in designing a product. Because we said that we are designing, remember we are designing for medical or biomedical equipment or things in the biomedical field. So we looked at how to do the design thinking or the engineering design. And we looked at what is called how to ask, research, imagine, plan, create, test, and improve on your design. So we looked at this, and we said it is iterative, and we are stressing on the point where you are creating a prototype. That is where 3D printing comes in. So go through that, and just know that you just don't make something from scratch, or you just don't make something from day one and it works, but there is an iterative process that you normally have to follow, and that is what the design thinking is all about. So those who didn't understand any question there, you can ask, but the recording also I think has been availed, or will be availed by today. Okay, then we started looking at computer. So these other ones we looked at what temperature, and before you print, you have to know that there's temperature which affects the quality of your work. There is chemicals like water, acid, those can affect your 3D print. So you just put those into consideration. And you have to know this. Don't be surprised when something you printed breaks after some time. It's because of maybe heat or temperature or something like that. So yeah, so we looked at all that. You can review yesterday's recording if you don't have. Then we looked at, we introduced CAD, computer-aided design, the various type of software that are there. And we were looking at surface solid modeling. We looked at something, the most common software. We are going to review this part. We looked at solid modeling, whereby we said that the solid modeling software, it represents a solid object. Like, for example, a car, even a person. You have got flies. We are making biomedical equipment. It's used to represent them in solid form, and they include some extra features which are very nice, like engineering analysis. Please mute if the person talking. We looked at engineering analysis, whereby you can look at thermal analysis, temperature, humidity, temperature, wind, all those kind of analysis, the strength of the material, graphics. Some even can do an animation, meaning you can even explode. We can be able to see one later on, or you can find out. It's an advanced topic, but you can be able to explode your assembly and see what parts consist, the design consists of. Like if it's a car, you know that the car has got the chassis, it has the seats, it has a bonnet, it has an engine, it has got the door, the boot, the bonnet, the front, rear, trunk, all that, the wheels, side mirrors, all that. So if you are designing using SolidWorks or Fusion 360 or Tinkercad, then you can be able to explode it, like you separate them in some kind of animation so that you see what's going on inside, or how are those parts connected, the bolts, the nuts, where they're coming in, the screws and all that. So you can be able to do that. Some also use mathematical principles, so they can be able to, you can put mathematical formulas, and then it can automatically draw for you something. Like if you want to do a screw and a nut, and maybe from your mechanical engineering, you know some equations used to calculate the screw gauge or the diameter, or all those kind of equations. You can put them into that 3D CAD software, and then it automatically generates for you, or it like draws it for you. So it's very interesting what you can do with this software. So we looked at surface modeling and solid modeling. So surface is whereby you can be able to see surface is inside it is hollow, but then the solid, something solid is something which is not hollow in the inside. So, but the main thing here that we are supposed to learn basics of CAD in terms of if you can be able to design something simple, and then you share it with us, then we print it for you. Our main objective is not to make you like a super pro that you can design an aeroplane, you can design some but at least for this course, your objective is to design something, whether simple as a box with holes on the sides. That's it. You are to design it, and then you send it to me via the WhatsApp group. And I'm not seeing people sending. Like yesterday's session, no one sent. I'm wondering why. So just even immediately now, if you can, share the STL file with me, and then we will 3D print them for you. So parametric modeling, then we looked at extrude. We did all that. So today we want to look at revolve, but I'll just go through whatever we did yesterday briefly. Then we look at the revolve, then we look at loft, how to do loft, and then cut. I think cut we had already done. Chamfer and fillet we had already done. Then Tinkercad, we are not using Tinkercad, we are using Fusion 360. Then that will be the end. So everyone, did you try doing something yesterday? Guys, did you try doing something? Yes. When you walikuwa na shida, do you have yes, please, whoever is talking, please mute. Please, whoever is talking, please mute.
Hello, Ivan. Hello.
Yes. Can you, who wants to share their screen and show us whatever they have done or where there is a problem? I'll briefly go through whatever we covered yesterday. So just start Fusion 360. In short, just start Fusion 360. And then you show me. So those who are in Nakuru, when we come to Nakuru, I don't expect us to spend time going through the basics, like extrude. I've done it so many times in class. And remember, a card is not the whole thing. Is there anyone with a problem who wants to share? Kuna questions? You've been waiting for the code. Okay, so guys, I want you to understand one thing, okay? That after the class, we can be able to share the recording maybe the next day, okay? So because we have to upload it to online, we have to upload it online, and then Lake Hub. I have a Google Drive where I am uploading it. Then Lake Hub, Malin, the guys will upload it to their YouTube channel. So just be patient. And if you like, there was cohort 1. You can go to cohort 1 and then you look at the videos of cohort 1, or even because I think on the first day we designed something, the second day we designed something. I think we've been designing things daily. So you can go through all those and you will get the basic concepts like shell, iso extrude, okay? So you should not use that as an excuse for not to have done something. Because ulikuwa unaona, and this thing is about tinkering, you like play around with it. So Carol, yeah, go online, go to that YouTube utaona. We have already shared today's work, yesterday's class, so she will have to upload it to their YouTube and then share link. But just go to YouTube, Facebook, just go to YouTube and look for Lake Hub Academy. Then you'll see the videos. I even did last year. We have a lot of videos there, which I'm just repeating them because of you guys. It's a new batch. Okay, so anyone who wants to share their screen or who want to tell us whatever they have done? Is there anyone who wants to share? Before we go to something next or a different command. Gloria Burungi. Gloria, are you new today? Hello? Gloria? Andrew is like you joined with a phone. I don't know why you are joining with a phone and we're having a hands-on session. Guys, who wants to share with me what they have done yesterday? Can you hear me?
Yes, you can.
Yes, can you show me what you've done? Okay, if you don't want to talk, let me continue because now I'll be wasting time waiting for you and you don't want to talk.
I beg you give a recap because some of us were absent. Hello.
Yes.
You just give a recap.
We are going to, yeah, I'm going to do a short recap of whatever we did yesterday.
Yes.
And then I request you to follow along with me, have your Fusion software, and I told you to get a mouse. So get a mouse and then the class will